Okay. I do not have the statistics on these, I just didn't have time to compile them. There were a few people who did very well, very few out of 70, less than 10% probably. There were quite a few people who did really poorly, and a lot of in between. You guys get to evaluate what you should do, if anything. I will tell you this was the easiest test by far in this course. By far. In this test you only had to analyze existing code and actually trivial code at that. In the coming tests, you will have to analyze more complex code. Remember last week when I told you one of the class rules? I don't remember if it's class rule or whatever. Did you have to think like a computer? You have to execute it like a computer. It gets complicated. You can't do it. You cannot, some of the stuff that is coming you cannot do in your head. You have to write down and keep track of where you're at. So, not only that, you're going to have to write code. You're going to have a a written description of what something is supposed to do, and you have to write the code to do it. And it's not close. The code has to be correct. This is a programming language class. Therefore, the code has to be correct. Okay, if and when you have, well, first of all, any questions on any questions on any of the questions in general? If you have a particular question about your answer, then see me during the lab period. Right? If it's a question about the material itself, let's address it now. Question?
Is case used anywhere else outside of a switch, or is it never used anywhere else?
I think it was only used within a switch. Any other questions? Nope. Nope. It's documentation. I guarantee you will never write anything in there that's not documentation. If you do, I would reject your code review. That's the answer. If I would reject the code review, it's wrong. Simple as that. In other words, if you put, I went skiing this weekend, I would kick that back. Because the question would be, how does that help the next guy do anything with this program? It doesn't. In fact, he may think it's code for something, who knows, right? Okay.
Just put 0.
Let's get started. 2 weeks from tonight, we'll have exam 2. Exam 2 will consist of everything in the entire class, as all exams will. But it will focus on the stuff we have covered since exam 1. But all programming languages build on the previous parts of the programming language you learned, so you can't forget any of them. Implicit homework. Read, study. You have to do that. One question last week, I promised to answer inside of the 4 statements. You can, in fact, declare the variable. Just closing the loop on that. A while loop. Let's talk about while loops. While loops are actually quite simple. When you enter the while loop, it evaluates the expression, whatever your expression is. And if this is true, it says while true, it does whatever is in here until it loops back up. And then it evaluates the expression again. Simple, straightforward. It really is that simple. Now then, here is a wrinkle. Unfortunately, they use the keyword break for 2 different things in C. They use it as part of a switch statement, as the statement that says in the switch, That's what break effectively does, is in the switch, wherever you are. Somewhat similarly, break ends the loop. Okay, break. Break says exit the loop. That means you will start executing right after the while, right after the loop. Because break applies to the for loop, to the while loop, and to the do while loop. Okay, so you reach a break statement, and it can be buried inside of multiple ifs and everything else. It only applies to the innermost loop that it is in. Okay? That is what this break will do. I'll give you another example in a moment. Except for a break, if it reaches the end of the loop, it comes back up and tests the condition. Now then, there is another construct which is not reused in another statement, called continue. What does continue do? Continue says, stop executing at this point in the loop and treat it as though you went down to the bottom of the loop and then started the loop again. So continue says, don't do any of this, loop. That's what the keyword continue means. And it does everything else. It tests whatever the condition is and continues on. So break says, exit the loop. Continue says, don't do any more in this iteration of the loop, start the loop again. Let's suppose you had this loop, and you had a break statement right there, okay? This break will exit the innermost loop that it is in, and it will start executing right here. After the break, it will execute y plus equal 2, and since there's nothing else, it will then loop back to the outer loop, do anything there, and execute the inner loop again. But it's a different iteration of the inner loop. So break and continue apply to the innermost loop for all loops, for loops, for while loops, and for do while loops. Do while. It is almost just like the while loop, except the condition is evaluated at the end of the loop instead of at the beginning of the loop. What that means is that you are guaranteed to execute the code in here once, at least once. In other words, in a while loop, depending upon what the condition is, you may never execute the code in the while loop. If the condition is false, it will never execute the code. But the do while loop has the while test at the end, which means the code is guaranteed to be executed exactly once. At least once. While and do while are fairly simple and straightforward. Just a for loop that has the complexity, and that'll be part of exam 2, understanding that complexity of those 3 parts and what they do when they're executed, the conditions they're executed in. So be sure and study all of those. Questions about loops?
I don't really understand what the do while loop does.
Do you mean why do we have it in addition to a while loop? A while, okay, suppose, will the code inside this loop, inside this while, ever be executed? I said x equal to 1, y will not be executed. Right. 1 is not equal to 3, so this is false, therefore it'll never execute anything in here. I said y equal to 12. Will this code ever be executed? Why? Why not? You haven't got here. You're coming in here. The while is executed at the end of the loop, not at the beginning of the loop in the do while case. So this is guaranteed to be executed at least once.
Even if it's false?
Even in this case, y is equal to 12. It'll execute this. It'll say 12 is not equal to 13. This is false, and it'll exit out. But it will execute this once. That is the purpose. Is this perhaps overkill in the language? Maybe so, but remember, 60, 70 years ago, somebody thought, I really need this, right? So they put code into the compiler to compile it and understand it. And is this rare? Is this ever used? Every now and then. I've used it once in the last year. I think I used it last month once for some reason. Because I had something that had to be done once, guaranteed. That was why. Do I use it very frequently? No, and I don't contrive to use it or not use it, I just use it as appropriate. I just rarely find it needful. I don't do a lot of these either, right? Most of the loops I do are some flavor of for. Okay, now let me tell you what a bad programming practice is. While true, then put the condition you're trying to test in the middle of your loop somewhere and say break. Today is September 21st. If anyone submits anything after September 21st with that construct, it will get a 0. This is guaranteed to fail any code review I give. It is almost guaranteed to cause me to rewrite code if I come across it in code. It is terrible. Why is it terrible? Why do you think it's a terrible programming practice? Well, but putting a condition here and then doing a break.
Because it's unclear.
That's another good reason. It's unclear, right? You are deliberately circumventing the purpose of the programming construct. But the real reason is, it is easy to write an infinite loop this way. I solved many problems, heralded as a savior. Seriously, taken out and bought drinks, applied with alcohol by the person who wrote it, right? And I used the opportunity as they're applying me with alcohol.
Can you repeat what it is that you don't want us to see?
While true. Never put while true up here. Big statement.
But aren't there like more complicated situations where it's not just easy to put the f double equals 4 instead of while true? So like what if there's a very specific situation where you want to test whether x equals 4 and that's part of some code in the middle? Wouldn't there be is there more literally never a situation where while equals true, or is there like never in this class type thing?
Never ever in the real world.
Oh, okay.
What it means is that you are writing your code in a insufficiently modular way.
Okay.
In other words, maybe you should take some code and break it up into a method or a function. Maybe your while loop is too complicated. Maybe it shouldn't be a while loop. There's any number of reasons and ways to do it other than that. All of which will be more clear. All of which will be more clear to the guy who may be you 6 months from now. So that's the rule for this class. Those are the reasons why you may not understand it now completely, right? But 10 years from now, if you're a programmer, I guarantee you'll understand it. Because you will probably have fixed someone's code that did this. And it's when you fix someone's code that did this, that is called an unforced error in sports, right? An error when somebody forces you because they tackle whatever you fumble the ball, that's a forced error, right? In sports, there's the term of unforced error. It means the person messed up for no good reason. That's an unforced error. We'll do enums first. Let's do enums. The reserved word in C that we are going to talk about is enum. Enum is the shortened word for enumeration. So if you enumerate something, that means you list it. So if you enumerate the days of the week, you have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So if I was going to enumerate that in the C language, let's say the days of the week, they'll even left off the word D, because nobody's going to misunderstand that. Okay, so that is a valid enum declaration. It declares what is essentially a type. It is actually a numeric type. We're going to talk more about that in a moment. And it calls it the days of week. And then it lists, it puts it in the enumerated list with names associated with them. The naming the naming rules for these names are the same as variable names, which means you can't start with a number, you can't start with an underscore, they are case sensitive, just like any other variable. Except these aren't variables, these are enumerations. So because this is a type, int is a type, double is a type, char is a type, so forth. Because this is a type, you can declare a variable of this type. So later on, let's suppose the program goes over here. Suppose you declare a variable called days of week, free lunch, for whatever reason. I'll tell you the reason. Today was my free lunch day at work. They seem to have settled on Wednesday. When we were in the other building, they did it 2 days a week. Okay, so you declared a variable, and just like any other variable, you can assign it a relevant value that is relevant and correct for that type. The only relevant values for this type are what is in the list.
So you need to put enum before days of week when you're declaring it.
Nope. I declared a type called days of week, which is just like int, just like double, so forth, except I can declare it, and I can define what the valid values are. I declared it over here, and then later on, after I had already declared it, I declared a variable of type days of week, and I gave it a variable name called free lunch, and I assigned the variable free lunch to be Wednesday.
Does Wednesday have to have quotation marks around it or no?
Nope. In fact, you will get an error.
So basically what this is doing is we're making our own custom type and then setting the possible values for that type.
That is exactly correct. Why would you want to do this, you might ask yourself? Makes your code a lot more readable, a lot more meaningful. Okay? Now, as it happens, an enum is actually a numeric type. Okay? It is an integer type, more specifically. It is just hidden. It's not necessarily even hidden from you. We'll get to that in just a moment. But it is a numeric type. So when I declare this, underneath the hood, behind the scenes, if you will, the first one gets the number 0, just like an array index. The next one gets 1, the next one gets 2, so forth. That is the underneath number it actually gets.
When you use it in a conditional, do you have to write like if free lunch equals Wednesday, or do you write if free lunch equals 3?
You should write if free lunch equal Wednesday,
Okay, thank you.
or whatever value. You can even compare two different variables to see if they're equal to each other.
Does this mean you could compare and say Tuesday less than Wednesday is true?
Not with what we know so far.
Could you have like, or should I just let you get to it?
Let me get to it.
Okay.
Okay. Are there any questions so far? We're going to expand on this, just make sure we understand the basics. Okay. Now let's suppose I'm not thrilled about being a zero relative person, where things start at 0, because by default, if you do not do what I'm about to do, they start at 0 and go up sequentially. But you can assign specific numbers to those enumerated values. And then those are the numbers used. If you don't specify, the compiler will start at 0 and go on. If you do specify, the compiler will use what you specify. And behind the scenes, it is actually doing numeric comparisons, by the way. It's not doing string comparisons. This is only for the compiler to interpret. And it knows what Wednesday is. It knows that Wednesday happens to have a value of 7, and that's what it actually assigns to that variable. You can start at 0, yeah. You mean suppose I put 0 here?
Yeah.
Sure. You can start at 0. In fact, you can put any number here that you want. It has to be an integer. It has to be an integer. Now, does it have to be a 32-bit integer? I don't recall. For our purposes, a relatively small integer. And relatively, by the way, 1,000 in computer terms is relatively small.
If you assign one, or assign a number to one of them, do you have to assign a number to all of them?
No.
Or if you assign it to one and then it just from where you stop assigning, does it start going in order?
I will have to look it up to be certain, but I'm pretty sure that it starts from the number you last assigned and goes in order. Now the question is, what if you have holes, right? The question is, what if you assign the same number to 2 different enumerations? I think you're allowed to do that too. I will make certain of it. Yes, I will look those things up to make sure. But underneath the hood, in the actual programming, these things are numbers, right? They're just syntactically making it nice for you to do things with meaningful names. There's that term again, meaningful names. Makes your code much easier to read. Okay, now here's the other wrinkle that I'm just going to tell you. This is a throwaway piece of information. When you do computers, you store data. You store data typically in databases of some flavor. Right? There's multiple flavors of databases. Most of them are SQL databases. There will be some people who will tell you NoSQL is the coming thing. Don't believe it, it's not true. NoSQL has its place and it has its uses. But by and large, we will stay with SQL for a very long time. But anyway, the information is stored in a database. So suppose we're going to store days of week for free lunch for Andy in the database. Suppose different people get free lunches on different days for whatever reason. Kind of defeats the purpose of team building and whatever, but let's suppose. Okay. That number has to be stored. So how do you keep the numbers in the database in sync with the numbers in the program? Somebody comes along and makes a change. That's a problem. Therefore, some places, not enough in my humble opinion, but some places have the numbers defined in the database. And then they read the database and they generate code. They generate the enumeration so that things cannot get out of sync. So always remember, when you're programming, when you're doing anything, there's a real world out here, right? We're keeping track of Andy's free lunch. We're keeping track of Andy's bonus, or Andy's inflation-adjusted raise, or whatever it is. Okay? Real numbers. You're keeping track of your car payment. How much of your car payment went to interest, how much went to principal. The real world keeps track of all this, and that stuff matters, right? It will keep track of the day of the month that your payment is due. And that's going to be a number like the 10th. But what they will also do is say, okay, suppose the 10th falls on a Sunday, then your payment is allowed to arrive on the 11th because the Postal Service does not operate on the 10th. And yes, most of us do electronic debits and transfers, but some people still write checks. I read an interesting article. Stupid things boomers still do. I had 40 of them. And yes, some of them are stupid. Most of them are stupid things that boomers still do. Not me. The only check I write is to the gardener, because that's the only way he takes payment, right? Except for that, I don't think I write any checks for anything. Comments? That is enumerations.
So if you're not using it for free lunch, which has already been declared as part of days of week, is Wednesday not like a reserved word everywhere else also, or is it only when it's used as it relates to days of week? A variable with days of week. So basically, can you use the word Wednesday anywhere else?
So in other words, can I come along here and say, You might get a syntax error. Go to the online compiler, try it, see what happens, let us know
Okay.
after the next segment. The short answer is, I don't know. Knowing how compilers and everything are written, particularly the C compiler, I bet you will get a syntax error. But I could be wrong, because the compiler has sufficient information to differentiate it. Yes, I've actually fixed compilers. Ashamed as I am to say it, I actually had to fix the COBOL compiler when I was sent to Midland, Ohio once. I wasn't, yeah, that is why I was there. So I know how compilers work. But the point is, what is the semantic information the compiler has? The compiler has sufficient semantic information to know that he can only assign Wednesday to something called free lunch. Right? If he has an integer, a variable called Wednesday, and he wants to assign something to it, well, because it's an integer, there's an interesting casting question here. So you could probably write bad code. That's why I think the compiler is going to give you an error. And that is why in later compilers, you cannot do this. You cannot simply assign the enumerated value. You have to preface the enumerated value by the type dot enumerated value. Because later compilers saw the issue of lack of clarity. They could figure it out, guaranteed, right? The compiler has no trouble figuring this out. But they've also said, we want people to write clear programs. We're going to do everything we can to help them. So for instance, in C#, you cannot do that for an enum. You have to write days a week dot Wednesday to assign it. And you've increased the clarity. You've typed a little bit more, but with IntelliSense, you type DAY, and it's going to suggest the rest of it. You just push the next character, tab, space, whatever the next character is, and it fills it in for you. In most integrated development environments. Unless you type too fast like I did today. I had to type the word country for some reason, and I didn't get off the shift key, so it's capital C, capital O, UNTRY. Compile. Why is it not compiling? For C#, well, this actually happened to be TypeScript, to tell you the truth. But it's case sensitive too. Just like JavaScript, Java, C, C++, C#. But fortunately, we have very fast computers, so it gave me the error very quickly. We're not quite done with enumerations. Just make sure we understand all this. If you don't assign it, it'll assign values for you. If you assign values, you're going to assign whatever values you want.
2 questions. First one is, for Saturday all the way down there, is there a reason why I didn't put a comma, or should it be like that?
There's 2 answers to that question. From one perspective, it should be like that, right? But from another perspective, for instance, in C#, you can do that and the compiler will not complain. I do not know about C and C++. Right? The reason it allows you to do this is so that you can easily continue adding without having to change that line above it. That's why it allows you to do this in C#. Right? It doesn't allow you to do analogous things in C# for initializers, which is a little inconsistent in my view, but they didn't call and ask.
So if we put a semicolon, then it would be the end of the continuum of all,
If you put a semicolon where?
after 13.
That'd be a compiler error.
Why is that?
Because you can put a comma or nothing. Just the way the language is.
Isn't it, I'm trying to understand because, like, usually we put, for example, in Wednesday right there, there's a semicolon to that, and that's the end of the,
That terminates a statement.
yeah,
This is not a statement.
what is it then?
It's a declaration.
Where's the end of it?
The end of it technically is this closing brace. Right here?
Yeah.
That actually makes sense.
And then
So this is a
also,
declaration.
also that in Wednesday is a compiler error because the Wednesday is declared already designed.
You mean this one? Is your compiler error?
Yeah.
Yeah, I thought it would. Not because it couldn't figure it out, but because it says, I want to stop you from doing something you might not should do to make things unclear. Did you try this one? I know it works in C#. I do not know if it works in C. It does? Okay. Okay. One of the unfortunate things about C, and we will see this in structure declarations as well, when we get to structures, not tonight. Okay, so let's say I'm making a simple enum. Let's call it and let's suppose that I'm just doing Ford and Chevy, for whatever reason. So car makes, I have Ford and Chevy, okay? I have declared the type car makes. Now, I can also say my car like that, and this does two things. It declares the type, the enumerated type, called car makes, and it declares a variable called my car. I personally hate this about C, but it's the way C works. When we do structs, it's going to work the same way. Not only can I say my car, I can also initialize my car to Ford, which did happen to be my first car, Galaxy 500. Bought it from my brother. Got a great deal. Not only that, I can declare multiple things. I can declare this is a variable of type car makes. The variable name is my car. Because I am preceding this variable name, your car, with an asterisk, which is the pointer symbol, I am declaring a pointer, a car makes pointer variable, and I happen to be assigning it to a reference to my car.
So in front of my car, you don't have to add car makes as to show like the type?
No, because, notice, remember when he said I had to put a semicolon here?
Oh,
He was correct to finish the declaration of this type. I haven't put a semicolon here because it declares the type and then instances of the type. And here's the terminating semicolon.
Okay, got it, thank you.
Hopefully you're beginning to see why I dislike this. I dislike the fact that C allows you to do this for structs and for enums. It is a little bit consistent in that you can say int x is equal to some value. I didn't tell you this, but I probably shouldn't be consistent. You could declare multiple variables of a type in a line. You should never do that. Makes it unclear. Your eyes don't track to the Y. Human eyes will not track to the letter Y. That's why you should on separate lines. You have made it much more clear. Yes, you've added a couple of extra lines, so what? We have these cool little scroll bars on mice now. Believe it or not, there was a time when a mouse didn't have a scroll bar. So, it is consistent in the sense of it's following along with that. You can declare variables after the type. The fact that you're making up the type is a little bit beside the point. Regardless, this is how the C language works. So you see your implicit homework? Just went from this about enums to this to understand variable declarations after type specification. The fact that int is an inbuilt type is beside the point. You can think of this enum car makes as your definition of something like an int. It actually is an int under the hood, right? And then you can declare variables after it, and you can even initialize the variables. Enums give meaning to things, semantic meaning. Semantics means, semantics really is the definition of meaning. Later on, you guys will come to find metadata, which is the definition of data.
Can you reiterate why there's a comma after Ford and then you use a semicolon at the end somewhere variable?
Because these are two different variables. separated by commas. And instead of a semicolon here, I could have put comma and more. So it's just like doing this. Int x comma y comma z. Except one of them you can say is a pointer to that type and give it a name, your car.
How do you output the name Wednesday if it just represents an enum? Because you said when you were declaring it that they were not string literals. So if I wanted to say printf free lunch, what would come out? Would it be the string literal? I mean, would it be the word Wednesday or would it be the number?
It would be 7, the way it's currently defined.
So it would be 7. So like, how would you get that information to print it out? Is what I'm saying.
How would you get the name Wednesday?
Yeah.
There may be a function to do it. I have to look it up.
Okay.
In C# and well, certainly in C#, you can get the display name, right, which would be Wednesday, right? But even in C#, they are still numbers,
Okay.
one way or another underneath the hood, right? But in C# you can absolutely get that name. In C#, you can do even more things in C#. Right? But that's a good question. I'll look up to see if and how you can get the string Wednesday out. I believe you can, but I'm not completely positive. I'll have to look it up. Because that would be a very reasonable thing for someone to want to do.
Yeah.
Okay, questions about enums? Implicit homework. You have to read, you have to write programs, you have to try, you have to see how they work. Do it with pointers, make sure you understand how pointers work. And references and everything else. Hopefully after that set of tests, that was a trivial test, you now believe me. You can't just take things in and output them on a test. You have to truly understand them. Okay. Next operator we're going to learn about is the sizeOf operator. It's used frequently. Every result of the sizeOf operator is the number of bytes. Now, as we proceed, we're going to talk about the different things you can pass to sizeOf operator. It is, in fact, part of the C language. It is not for our purposes, it is part of the C language. So, we had types called int, char, long, double. These are types that are specific to the language. I may have missed one. Maybe not. So, if you pass a type to the sizeOf operator, you will get the number of bytes for that type on that computer system. So on most computer systems, those are the numbers you will get if you say sizeOf int, sizeOf char, sizeOf long, so forth. Because on most computer systems, a character variable is 1 byte, 8 bits. On most computer systems, the ones we operate on, an int will be 4 bytes, 32 bits. A float will also be 4 bytes, 32 bits, although it has a different internal representation than the int. A double and a long is twice as big as the int. That's why the term long came about. It will have a size of 8 bytes. A double is twice as big as a float in terms of the number of bytes it uses. So it will also have 8 bytes. So this is what happens when you pass a type name to sizeOf. What is really happening is it's generated by the compiler, because the compiler knows the size of those types. So it's just the compiler generates that number for you. Right? The reason it's important to get the number via sizeOf type name is because it allows your program to run correctly on any computer system, if you use it correctly, if you use the value correctly, which we're going to see in a minute. So in other words, let's suppose you have a 20-year-old computer. These numbers might be different. Or suppose 20 years from now, you have these tiny little computers that do gargantuan things. These numbers may be bigger. But if you write your program using this syntax, it'll all run correctly. Now let's learn about some more things. Any questions about this? It's essentially producing a static number. But it's important because even though it's a static number on that computer system. Everybody good so far? Now let's suppose you say, we haven't talked about initializers, but that would initialize the values in that array to 0 through 9. And you don't need the initializer, it's not relevant. Right? Because no matter how much you initialize it with, that array is going to be 10 integers wide. What do you think size of array will be? ARY will be. No matter what you're doing, the answer of size of is always number of bytes. 40? It would be 40.
But didn't you say at the end of every array is always a null type or something?
Nope.
Okay.
That is the convention for a string contained within a character array.
Okay.
Okay? So size of array will be 40. Now later on, we're going to get to things like this. Where you're passed an integer array in your code, your little function, you're passed an integer array, but you don't know how big it is. So how do we find out how big it is? Fairly straightforward. You simply let's call it elements. So to determine the number of elements, you take the size of the array and you divide it by the size of the type of array. So suppose this is all one program and I declared this array up here. Suppose I'm just going to return the number of elements. Okay? So I declare this array up here, which has 10 integers in it. If I call that, it would pass ARY, which has 10 integers in it, and then it would perform this function. It would say size of A, which we've already determined will be 40, divided by size of int, which we've already determined will be 4. Who knows what 40 divided by 4 is? It is 10, which is exactly how we declared the array. That's all there is to size of, really. I mean, this will apply to structures and other things as well. You can say size of some structure. We haven't talked about structures yet, but we will eventually. And it'll be the size of what that structure is, if it's the structure type definition.
Could you explain what we're dividing again?
So that's size of int. Right? In other words, this is the size in bytes of what was passed in. This is the size of an integer, because we know it's an integer array in bytes. So if I divide the size of what was passed in by the size of each element, I'll get the total number of elements, which is why I call it element. It keeps your code consistent. it keeps your code portable, and it keeps your code correct. Plus, you won't necessarily know what the size of this is, because you can declare an array dynamically in another part of the program. So your program is not a fixed size. It could be a variable size, and you may have to know what the size is. Because suppose you're past that array, you don't know how many elements in it, but you want to step through each of the elements in a for loop. You have to know what the limit of the for loop is. This is how you find out. For instance, it can be used for other things, but that's an easy for instance.
So that parameter with int, with empty brackets a, that's declaring a as
An array. As an integer array. Array of type integer. Size up. In and of itself, that's all there is to size up. There's a few use cases there. When we start talking about malloc and free, well, malloc anyway, we're going to talk about more use cases, which is the next thing we're going to talk about. Let's talk about malloc. Malloc stands for memory allocation. That's what the M is for memory, alloc is for allocation. Okay, free is the opposite of memory allocation. It is giving memory back. It is saying, I'm done using this memory. Return it to the system for reuse, whoever needs it. Memory allocation next time. That's what free is for. So malloc and free go together. Okay. All right. So here's the question. Do you think malloc and free are parts of the C language, or do you think they are library method invocations? Who thinks they're part of the C language? Everybody raises their hand like this. I don't want to be wrong. Who thinks they're library method calls? Who has no clue? Okay, very good. I have no clue is the beginning of wisdom, the beginning of knowledge. That's the most important thing you can say to yourself. I don't know. And then you go find out. It's the people who are unwilling to say, I don't know, who don't get very far. The answer is, it is a library function. So, malloc. What does malloc return? Effectively, this is what malloc is. It will return a pointer, and it will return a pointer to the number of bytes that you told it to allocate. Or it'll throw an exception saying, I can't allocate that memory. But for our purposes, it's going to allocate the number of bytes you ask it to, and it's going to give you a pointer, which is a reference to that memory. Okay? So let's suppose I wanted to dynamically create a 10-character array. That is how I would do it. Not a 10-character array, a 10-element array. I would say, I don't know what computer system I'm running on. I might be running on the Apple 35, the iPhone 35 at some point in the future. So I have no idea what sizeOf means. But I don't need to care, because I'm going to make my array big enough to hold 10 of them, however big they are. So then, and frequently by convention, people put a lowercase p in front of the name, so that when they look at the name, they can say, okay, it's probably a pointer. All sorts of conventions like that about how to name things. That's a common one. But now, you've allocated a chunk of memory that on our systems happens to be 40 bytes. Oh, and by the way, that's probably more likely what you would do. Because you don't really know what the number of elements is going to be yet. Because you're reading them out of the database, somebody's entering them on the keyboard, whatever, right? You don't know. Because that's how data is in our world. Right? You guys probably have investment accounts and you lost $10. I probably did today. I have investment accounts and I probably lost $10,000. Because I'm old. And I've been investing for a while. It actually wasn't that bad. I only lost $5,000. That's why I'm stupid for looking at it regularly. I shouldn't. You should invest, forget it. Don't look at it. Look away. Look away. That should be the answer for the economy today. Look away. But don't worry. It'll recover. Everything is cyclical, right? As depressing as it may seem to you, as depressing as inflation may seem to you, patience. It will come back and everything will be fine. I may be dead by then, but it will be fine. No. Typical recovery is 18 to 24 months. Worst case, 24 months typically. Okay, we've allocated a new array. How can I access this array? Remember, if you recall from last week, a pointer and an array are the same thing. If I declare this int array, if I use ARY, I can use it as a pointer. Similarly, I can use pNewArray, which is a pointer to a set of events, as an array. Perfectly valid. I have assigned 13 to the fourth element in that chunk of memory I assigned. Make sense?
Can you explain again the array?
Okay. If I have declared a pointer, the pointer will have a type. The reason it returns void is so that it can be general, so malloc can work on any type, because this is just returning a pointer. It's returning a memory address. That's all it's returning. And that's why I have noted void star. The compiler will say, okay, we're going to treat that chunk of memory as a bunch of integers, which I, the compiler, know are 4 bytes wide. On the iPhone 35, they may be 16 bytes wide in the future. Who knows? It doesn't matter. Okay. So this is a pointer to a chunk of memory. I can take that chunk of memory and index it in the C language, because the compiler knows it's an integer array. It's to be treated as an integer array. So the compiler knows that when it's indexing with 3, it goes to byte 12 by multiplying it times 4 inside. In other words, when it generates the code, this isn't the code that gets generated. It generates assembly code, right? And in that assembly code, it takes whatever is passed here, multiplies it times sizeOf, and goes to that location in this pointer. That's what is actually happening under the hood. For our purposes, we can nicely say piece of memory, index 3, or index I, if you want to. And do whatever we want to with it. Get a value out of it, put a value into it. Whatever.
Why is it equal to 13 though, not 12? If it's going to be times.
No, I'm just assigning a random value.
Oh.
I'm just assigning a value to it. After the equal, that's just assigning a value to this piece of memory. An integer value of 13897 to that piece of memory.
What's the meaning of 13897? Like,
It's just random. It's just a random example I picked. Means nothing.
of memory?
No, it's a random example I picked of a number. How old are you?
18.
Okay. or end or no?
Does the new array have to be a pointer, or can it just be a regular integer?
It is. It's the same thing. That is the point. That is the point. An array is a chunk of memory. Now, you could allocate that chunk of memory statically. You can allocate that chunk of memory dynamically. It's still a chunk of memory that you can do things with, like index it as though it was a set of integers.
Did you already have to declare a new array where you said integer, pointer, new array? Or is that also declaring a new array?
You mean right here?
Yeah.
This is the declaration. This is the type, integer pointer, and this is the name I picked, P new array. I could have picked PABC, I could have picked anything. Call it P my array. Doesn't matter what you call it. As long as what you call it, you use consistently.
What library is that part of?
malloc is part of stdlib.h, which I don't think we're going to get to tonight, which is why it's down here on the bottom, header files and live reference. Now, that's why that's down there, because you already use stdio for printf and scanf, and it has a number of, quite a few other things in it. stdlib stands for standard library. It has malloc, free, and a bunch of other stuff in it too. And there's a lot of other libraries. I can't remember where string compare, string cat, and those are. I think they're in standard library, but they may be a string.h. I'll have to look when we get to that point. But that's the beauty of it. You don't have to wait for me to look. You can go look. Just put in C string library into Google. It'll tell you what library is there, or something like that. Okay, so that's how malloc works. Memory allocation. There are additional things called calloc and realloc that I will let you look up. Realloc works on an existing pointer and reallocates space. In other words, suppose you need something bigger. Suppose you made it 10, and then you come to find, oh, I need 20, for whatever reason. Realloc can help you do that. You can reallocate the pointer. You can look those up. calloc is another one. I actually believe there is also a dealloc, D-E-A-L-L-O-C, which deallocates memory, but pulling that from memory.
Did you say D or V?
D. That's the one I'm not positive about. The reason is because you should use free. I don't remember for certain if the result of free is void, which means no value, or if it's an int. I just don't remember. I'm going to look it up later. But the real point about free is you pass it a pointer when you're done with the memory and you want to give it back to the system. I'm done. You can have a back system to do whatever you need to do with it. This is how dynamic memory systems work. Now in C, these things are pretty unambiguous and clear, and there's no magic to it. If you allocate it, you have to free it. In C++, in general, if you do a new, which is the same thing as malloc, uses malloc underneath, right? You have to do the delete to give the memory back. Right? Although they've made enhancements to C++ where they do things automatically free with a garbage collector. You'll learn all about garbage collectors if you ever take a data structure course. That's not true. You will learn the basics of garbage collectors, because the details of garbage collectors are very complex to be efficient. But in In C, to give memory back, you call the function free, and you pass it the pointer. So in our case, what we would want to do here, after we did whatever we were doing, we would simply call free and pass it the pointer that we previously allocated. And then you have given that memory back to the system. Now that doesn't mean you cannot commit errors and continue to use that pointer, because you can, syntactically. After I do that, I can then say, after that free, I can then say p my array of 7 gets 63, which is my age. But what I may be doing when I do that is stomping on memory that has been allocated to someone else. But I still have a reference to it. So you should never do that. This is where most of the errors in C++ come from.
What does void free do?
That's the declaration. These are declarations of these functions when you import them into your program. That's a declaration. This is the use of it.
Why does it say void m there instead of just a pointer? Because like I know what it's referring to, but I thought you were saying that
the star very large. It is saying void pointer. I just gave it a name m.
Right.
It takes a pointer and it operates on that memory and you give it back to the system for somebody else to use at some point. It has to say, here's the memory I'm giving you back. And it has to give a reference to that memory. That's what that parameter is. Because in this case, I allocated a pointer called pMyArray. I did whatever I was going to do with it. And then let's say I'm done with it. I call free and pass that pointer in to tell the system you can have that memory back for the next program or the next use in my program of memory allocation or whatever it is. So in fact, in most programs, this is rarely done. This is what is actually done, is dynamic allocation of memory and dynamic returning of memory. Because they are dynamic programs. And you have a limited amount of memory. We have much more than we used to be limited to, but we've discovered that no matter how much memory and processor we have, we find a way to use it. Like once upon a time, we were hard pressed to land the lunar module when it was just doing this, right? Limited memory, limited processor. More memory, more processors. We tell our car, go to Walmart, and then open our paper. Hopefully we're not doing that yet, but that is certainly what Elon Musk intends to do by the end of next year. Excuse me, that's what he says he intends to do by the end of next year. He has a lot of regulatory hurdles to jump, I'm sure. But all of that memory and processor found uses. We will find a use for it. Driving along the freeway today, I had the nerve to change lanes in my wife's Lexus without doing the turn signal, so the steering wheel starts vibrating because it could see those lines on the road that I was crossing. Some piece of memory and some piece of processor was running to figure that out.
Why didn't you use the turn signal?
Because I'm a bad driver in some respects.
Oh, okay.
You also have to own up to your mistakes.
When would it be advantageous to use the declaration of an array using malloc instead of just normally declaring it in my array?
When you don't know what this number is, when you don't know the number of elements. In other words, in some of the programs that you will do in data structures, I can't remember if any of these programs in this class have it, it'll start with saying, ask for the number of people. And it's a variable that the user enters. So if he enters 12, you would assign elements to 12 and then do this. If he says 100, you assign 100 to elements, whatever he entered, you would do this. So it's to use as much resources as is requested, but no more.
But you wouldn't be able to do that with a static array because you can't change the memory entry, right?
Strictly speaking, that's true. Well, technically speaking, that's true. Are there things you can do? That's the thing about C. You can do almost anything you want to. How safe it is to do it is another question. In other words, and when I say safe, I don't mean safe in terms of will it work. I mean safe in terms of can you do it in the right sequence and in the right order to get the right result every time. That's why we do certain types of programming and don't do other types of programming, because we have learned over the years this is a bad practice that leads to errors. Question over here somewhere? Okay. So that's sizeOf. SIZOf is important to understand because you're going to use it in memory allocation using malloc. Free is just the reverse of malloc. It's giving the memory back. This is how all C programs are written. Not all of your programs. You're writing trivial programs. But I'm talking about Mars-Landser programs, Space Shuttle Arm programs. My uncle tried to get me to come work for him to help him write the software to control the Space Shuttle's arm. I foolishly said no. Probably career-wise it was the right choice, but it would have been meaningful to have a piece of NASA on my resume and just to do something like that. But he wrote it all himself. And it worked great. Went out there, grabbed the Hubble. You remember when the Hubble had, no, you don't remember. When the Hubble was first launched, it had blurry images. You had to send the space shuttle up there to go out there and grab it with that arm. Then an astronaut had to wander around fixing the Hubble telescope. There you go. Then we got beautiful images. Roads not taken. Malloc, free, sizeOf. We did enum. Any questions so far? Because now you can see that the stage has been set to start understanding pointer arithmetic. Because indexing an array is not the only way to get to something, right? You can say, you can do things like P minor array. And now you're going to see why we have some of the shorthand operators. So after you do that statement, pint or PMyArray is now pointing to the fourth element of this thing you allocated. That's another way to get to index 4 of this integer array. We're not going to do that tonight. I'm just giving you that so that in your implicit homework, after you've read all of this stuff, you can start reading up about pointer arithmetic. And we'll talk about it more next week. Any questions? Okay, that's it for tonight. Anyone who still needs their exam returned, come get it, please.